Okay, this is a really good question. It's a little bit of a tough question, but it's conceptually deep. That's one of the reasons I put it on the homework. So you got a blind taste test between brand A and brand B, two colas, and the surveyor asks which one you prefer. So the results of the test indicate that 59 out of 100 individuals prefer brand A. So that's our assumption, our baseline assumption, our null hypothesis, that 59% prefer brand A. But part A asks us to conduct the hypothesis testing if we were to get different point estimates doing another sample, like 48, 49, 50, all the way up to 68 and 69 and 70 at a level of 5% significance. So unfortunately, that's pretty easy with StatCrunch. That would take a long time by hand. So to do that, we would just do, proportion stats, one sample with summary. Okay. Now, if we wanted to do, what's the first of them? It's 48%. So our point estimate is 48%. You can just do 48 out of 100, right? And we want to do hypothesis testing where the null hypothesis is that I think 59 out of 100 individuals, 59% prefer brand A. And we just want the alternate hypothesis to be that this isn't the population proportion. So I'm going to hit compute, and my picture's in the way a little bit, but we get a p-value of 2%. So what that means is that we're going to, at a 5% level of significance, we're going to reject the null hypothesis. We're going to reject the idea that the real population proportion is 59%. Okay. And so if you look at the question, it just tells us that it wants us to go do this for 49, 48, 49, 50, all these different proportions. So instead of opening the whole thing up and opening a whole bunch of different windows, you can just keep going back in. So 48, we would reject, right, the null hypothesis. What would happen at 49, right? We're getting close to 5%, but still not there, so we would still reject. Okay. What would happen at 50? Edit. Okay, so 50. Oh, there the p-value is over 5%, so we do not reject the null hypothesis. Okay. And as you'd expect, if you did it at 51, right, that's even closer to the null hypothesis. Now we're up to a p-value of 10%. We're not going to reject the null hypothesis here. And that's true all the way up. I won't do all the values. I think once it gets up around 66, we get close to a p-value of less than 5. Let's see. So that's still at 15 at 66%. 67%. That's at 10%. Getting closer. 68 is almost at 5. So let's see if 69. There we go. So 69 is the first value that we would reject the null hypothesis again, right? So what do we say? It was, I believe it was 50 to 68. Those are the values that we do not reject the null hypothesis. So 50 to 68. Okay. Those are all the values for which we do not reject the null hypothesis. Anything lower than 50 and higher than 68%, we're going to reject the null hypothesis. And then it asks us to construct a confidence interval at 95%. Notice that this is 95%, and before our significance was at 5%. Those are complements of each other. So I can actually just do this, hit edit. So a confidence interval for 59 successes, 95%. And our lower limit would be 49%. I think it's round to three places. So 494. And then our upper limit of our confidence interval is going to be 0.686. Okay. Now, what's really cool here, and the reason that this question is so valuable, is look at this, right? The lower bound is basically the same, almost the same as when you start rejecting the null hypothesis on the low end, and this upper bound is basically when you start rejecting the null hypothesis on the upper end. And this is what connects hypothesis testing and confidence intervals, right? So I just drew a graph of this real quick. So for all these whole values, right, we do not reject in the middle here. And the null hypothesis was 59 right in the middle of this. My scale gets a little smaller here as I move to the right on the paper. As I was running out of room, I started doing the tick marks smaller. But that should be directly in the middle. The confidence interval at 95% is the same as the hypothesis testing at 5% significance. Okay, so that's really the connection between hypothesis testing and confidence intervals. The last question just says, suppose you change the level of significance in conducting the hypothesis test to 0.01. And I hope at this point you kind of realize after chapter 9 that the smaller you make the significance, right, the less you're going to reject things. The larger the do not reject thing, the larger this area of D's would be, right? Because you don't want to make a type 1 error of accidentally rejecting a good null hypothesis. Because of the connection between the confidence interval, that means that a 99% would be the same as a 99% confidence interval, right? So if we're not rejecting more things, then the confidence interval is going to be big. If there's more D's here in the middle, right? Like if the ends were to expand longer and these R's were to become D's and some of these R's too, our confidence interval becomes bigger. Okay, so what would it do to the range of values for P's, the point estimate in the first part? Well, more point estimates, right, would not be rejected. Would not make us reject the null hypothesis. So the range of values would increase because the corresponding confidence interval would increase in size. Okay. So both the area that we do not reject the null hypothesis and the confidence interval at 99%, right, would increase. So I hope that makes sense a little bit. This is a very conceptually deep question, but it connects two big themes in the class.